Hello guys, welcome to my YouTube channel. Today we will be looking at understanding your data part one. So as a researcher or as an analyst, you need to understand your data. You need to understand the nature, the classification, the attributes of your data before you proceed to your methodology. So understanding your data will enable you to choose the right estimation parameters, will enable you to choose the best estimation parameters based on the classification of your data. So today we will be looking at understanding your data part one. So what are the learning outcomes? Today we will be discussing what is the data, the sources of data, the measurement of data, and how we can describe our data. So what is data? Data are units of information, often numeric, that are collected through various observations, collected through events or outcome of an event. So data are sets of values of quantitative or quantitative variables about one or more persons or objects. So what are the sources of data? So basically we have two sources of data. We have the primary data and the secondary data. The primary data is the type of data that is collected by researchers directly from the main source. There are different types of sources of primary data. We have the focus groups, we have the interviews, we also have the questionnaire. So the secondary data is the data that has already been collected through primary sources and made readily available for researchers to use for their own research. We have the stock market, the reviews, and the textbooks. So what is the nature of the data? Basically, there are two types of data. You have the quantitative data and the qualitative data. So under the quantitative data, which is always numerical in nature, you have the continuous data and the discrete data. While under the qualitative data, we have the nominal data and the ordinal data, which are categorical data in nature. So measurement of a data. What are the measurements of the data? So based on this section, we'll be looking at a nominal value and the nominal data, ordinal data, interval data, ratio data, discrete data, and continuous data. So for the purpose of this session, we'll focus on these types of data. Basically, there are different kinds of classification of data, but we will be considering this type of data. So what is a nominal data? A nominal data, they are categorical data, which are data which are in category, but they are not ordered together. For example, we have the gender, which is the male and female. We also have the dead or alive, the presence of a condition or absence of a condition. So nominal data can be divided into two. You have the binary and also have the multinomial. So we have this other one is they are categorical variables, but they are more than two and they are also unordered. We also have the region, the north, west, south, and east. So under nominal variables, these are categorical variables that does the first variables does not precede the other variables. For example, or the first variables is not superior to the other variables, or for example, the male is not superior to the female, neither the female is superior to the male. So they are in category, but they are not ordered. So we have the ordinal variables. The ordinal variables, the categorical variables, and they are also ordered. So the difference between ordinal and nominal is that the ordinal variables, they are ordered categories variables, whereas the nominal variables, they are unordered variables. So examples of ordinal variables is the strength of an agreement, the grades in schools. So the other type of measurement of data we will be considering is the interval data. The interval data is similar to the ordinal data. The difference is that the interval data, they can be discrete, they can be continuous, and they are also numerical in nature. So, and the measures differences over a period of time. You also have the age bracket, you have the time differences and temperature. While the ratio data, they are discrete, also similar to the interval data. They are discrete and continuous data, and they are also numerical in nature. The difference between it has a little different, is similar to interval data. The difference between ratio data and interval data is that the ratio data consider the values of 0, and you can do all sorts of calculations with ratio data, such as the addition, subtraction, multiplication, and division. So a typical example of a ratio data is the weight, the height, and the number of children. So we also have the discrete, which is also known as the count data, which a typical example of that is the number of children, number of accidents in a year, number of events, and so on and so forth. It's something, is a data that can be counted. It follows a Poisson and distribution. So we also have the continuous data, which is data on infinite scales, which follows a normal distributions. A typical example of that is height, weight, and response time. So categorical data. We're considering the ordinal data. A typical example of ordinal data is grade in schools, whereas we have those that score 70 to 100 falls under A, those that scores 60 to 69 falls under B, and those that scores 50 to 59 falls under C. So we also have the socio-economic status. We have the low income, the middle income, the high income. We also have the 5 Likert scales. We have the strongly agree, indifferent, disagree, and strongly disagree. So under ordinal data, it's a categorical data that are ordered together. That is, they are in rank and in order. So interval data, it's similar to the ordinal data, but the difference is that they are numerical in nature. So we have the age, we also have the income level, and the nominal data, like I said before, they are data that are categorical data, but they are not ordered, they are not in rank. We also have the gender, the marital status, the race, and the sales region. So ratio data, for example, what is your daughter's current height? You have the option, the first option is less than 5 feet, 5 feet inch to 5 feet, 5 inches, and so on and so forth. So describing your data. When modeling your data, we typically have a measurement of variables, which we refer to as the dependent variables, or the response variables, or the target variables. And this variable is usually typically denoted as Y. And we also have the explanatory variables, and we also call it predictor variables, independent variables, descriptive variables. And these variables is usually denoted as the X1, X2, X3, and Xn, or the vector component of X. So when you are modeling your data, you take into consideration two different kinds of variables. The first one is your dependent variables, which is always denoted as Y, while the second one is your explanatory variable, which is explaining the changes, which is responsible for the changes in the behavior or in the pattern of your dependent variables, which is also known as your Y. So Y determines your model. Your dependent variables determines your model. Your dependent variables determines your estimation parameters. Your dependent variables determine your estimation parameters, determines your estimation techniques. So the dependent variables determine the kind of analysis that you are going to carry out. So basically, your Y and your X, they have the same measurement categories, they have the same set of data, they have the same type of classification of your data, such as if your Y is a discrete variables, your X will also be a discrete variables. If your Y is a continuous variables, your X will also be a continuous variable. That is it. Under normal circumstances, they should have the same category, but this is very, very rare. Most scenarios usually have a mixed data where we have your dependent variable is a categorical variables, while your independent variables, they are nominal, and they are ordinal, or they are discrete or continuous variables. So regardless of the situation that we find ourselves, your Y is what you want to model. Your Y is the essence of your analysis. Your Y is the essence of your research, using the component of X1 and X2 and X3 to achieve the changes in the behavior of Y, or the changes in the pattern of Y. So we will be using an hypothetical example to explain that you need to understand your data before you proceed to your methodology, because the nature of your data will determine the kind of estimation parameters you are using. So we will be using a regression model for this hypothetical example. So the first one is if your Y is a continuous variables, that is, it follows a linear distribution in normal distributions. For example, your weight, the time, and length, and also stock prices. Your estimation parameters will be a linear regression or a non-linear regression. So if your Y is a discrete variable such as the count data, whereby you're considering the number of events, the number of children, the number of activities. Your estimator parameters will be a Poisson regression. So if you have a binary or a nominal categorical data as your dependent variables, such as the yes or no, the male or female, the pass or fail, the scratch, dent, and tear, you will be considering binomial or nominal or multinomial logistic regression as your estimator parameters. But if you have a dependent variable that is ordinal or categorical variables, such as the strongly agree, agree, disagree, strongly disagree, and disagree as your dependent variables, you will be using the ordinal logistic regression as your estimator parameters. So as the case for intervals and ratio, you will be using linear regression, interval regressions, ordered probit, or ordinal logistic regression. So the essence of this table is to explain to us that we need to understand our data. We need to understand the classification, the attributes, and the nature of our data, as this will help us to determine the best estimation parameters to use for our analysis based on the nature of your data. So based on the nature of your dependent variables. So in a nutshell, your dependent variables determine your model, it determines your estimation parameters, because the essence of your research is to achieve the changes or the pattern or the differences in the behavior of your dependent variable, which is also known as the Y. So going by this lesson, you will understand that understanding the nature of your data, most especially your dependent variables, will help you to determine your estimation parameters. Will help you to determine the best estimation parameter, because different kinds of data with different types of estimator parameters. So guys, thank you for watching. In my next video, I will be using different classification of your data and also using different estimator parameters. So thank you for watching. Kindly subscribe to my YouTube channel. I will be uploading videos from time to time so that you won't miss any of our lesson. Thank you. See you later.